This is section 2.3, writing linear equations. We're going to do some selected evens through this section. The first one we're going to start with is question number 2. If you notice in your book, it says write the equation of each graphed line in slope-intercept form. So the first thing we need to know is, what is slope-intercept form? Well, slope-intercept form is simply y is equal to mx plus b. And this is one of the most important forms or things that you can know when graphing lines, and in Algebra 1 and Algebra 2, y equals mx plus b. So what we need to do then is find what my slope is and what the b is, or where it crosses the y-axis. So what I can do is I can find 2 points on the line, and I can use rise over run. Alright, so if I look closely at this, I notice down here, right there, is a point, and that's on the line, and that happens to be 0, 1, 2, 3, 4, 5, 0, negative 5, and that's also the y-intercept. So I know just immediately that by looking at the graph that my b is equal to negative 5. Alright, so there's one part. And if I look at my graph carefully, I can also determine that there's another point on the line, and it is at 1, 2, 3, 4, 5. Right there, if you look closely, you can see that 5, 0 is on the line. And this is called your x-intercept. Now, I need to figure out the slope. So I could use my formula for slope, y2 minus y1 over x2 minus x1, and plug in those 2 points, all right, and come up with it. Or I can simply just count, because with slope is equal to rise over run. So let's take a look at these 2 points and see how far they go up. So it rises up 5, and then to the right 5. So my slope then is essentially rise 5 and run 5. So my slope is 5 over 5, which is simply just 1. So my equation then is going to be y equals 1x, or just x, and then my b was negative 5. So y equals x minus 5. So that's your answer there to number 2. Now let's take a look at question number 4. Question number 4 looks like this. This is a horizontal line. And so again, slope-intercept form is y equals mx plus b. And the b is your y-intercept. So where does it cross the y-axis? Well, it crosses right there, all right, at the point 0, 2. So my b is 2. So I've already figured that out by just looking at the graph. And then you're supposed to know that horizontal lines have a slope of 0. Think of it as skiing. If you're skiing on a flat slope, horizontal slope, then you're going 0 miles per hour. So 0. So my m then is equal to 0. So my equation is simply y equals 0x, which is just nothing, plus 2. So y is equal to 2 is the answer to question number 4. Moving on to question number 6. Question 6 says use the slope-intercept form, so that's y equals mx plus b. Use the slope-intercept form to write the equation of the line passing through the given point with the given slope. So I have a given point 1, negative 1, and a given slope of negative 3. So what I want to do, if I want to figure out what this is going to be in slope-intercept form, let's just go ahead and plug in everything that I know right here. So again, I like to label, this is my x, this is my y. So y then is negative 1 is equal to m, which we know is negative 3, times x, which is 1, plus the b. The part that I don't know is the y-intercept. Alright, so just working this out, solving for b, I get negative 1 is equal to negative 3 plus b. Add 3 to both sides, and I get 2 is equal to b. So I know my b is equal to 2. So my equation then, in slope-intercept form, would be y is equal to negative 3x, that's the slope, plus 2. And there's your answer for question number 6. Moving on to question number 8. The same type of question. I have to put it in slope-intercept form. Again, y equals mx plus b. And you could plug in everything that you have here, or you could recognize something important. Since my x value is 0, then I know the b is immediately, the y-intercept is negative 3/4. That's where it crosses the y-axis. So I already have everything that I need in the given then. So it's y is equal to m, which is negative 1/2 x minus 3/4. And there is your equation in slope-intercept form. Sometimes you just got to recognize and see what's given to you. Moving on to question number 10. 10 looks like this, and it says use the point-slope form. So let's write that down. Y minus y1 equals m times x minus x1, point-slope form. Use the point-slope form to write the slope-intercept form. So that's y equals mx plus b of the equation of the line passing through the given point with the given slope. So very similar to the last problems, except this time they want me to use the point-slope form. Alright, so again, this is my x and this is my y. So using the point-slope form, I have y minus y1 is equal to m, which I know m, times x minus x1, which is 3. Alright, so when you subtract, you add the opposite, so it's really going to be y plus 4 is equal to, distribute, 2x minus 6. Solve for y, since we're putting it in slope-intercept form. So y is equal to 2x minus 10. And that is your answer for question number 10 in slope-intercept form. Moving on to question number 12, the same problem, the same instructions. Use our point-slope form, so y minus y1 is equal to m times x minus x1. By the way, we use the point-slope form when we're given a point. This is a point. And when we're given the slope. So what we do is we say, alright, well y minus y1 is equal to m, which is 0, times x minus x1. Now minus a negative, so that's y plus 2 is equal to, when you distribute here, 0 times anything is a 0. Then subtract 2 from both sides, so y is equal to negative 2. So this is actually a horizontal line where it crosses the y-axis at negative 2. Moving on to question number 14. This one says, use the method of your choice to write down the slope-intercept form of the equation of the line passing through the given point with the given slope. So my method would just be, well, let's see what they give to me. They give me a point here, and they give me a slope here, so I'm just going to use point-slope form. That's y minus y1 is equal to m times x minus x1. Alright, so just plug in things. So y minus 3 is equal to 1/2 times x minus negative 1. So this is really y minus 3 is equal to 1/2 times x plus 1. So this is y minus 3 is equal to 1/2 x, distribute, and 1 times anything is itself, is 1/2. Now, let's add 3. So this is equal to y is equal to 1/2 x plus 3 and 1/2. Now we would never leave it as a mixed number. We would convert it to an improper fraction. So we would say, alright, this is y is equal to 1/2 x plus 7 over 2. 2 times 3 is 6, plus the 1 is 7. So 7 over 2. So this is the equation in slope-intercept form for number 14. Moving on to question number 16. Get to use our method of choice, and again I see a point and I see slope. So I'm immediately going to think point slope form, which is this right here. Y minus y1 is equal to m times x minus x1. And I just plug things in. So y minus y1 is 0 there, is equal to m, so it's 3/2, times x minus 6. Well, y minus 0 is just y is equal to, distribute, 3 over 2x, and positive times the negative is negative, and think of this as 3 over 2 times 6 over 1. You could do some canceling if you wanted to. And so you get 3 times 3 is 9 over 1, or 3/2 times negative 6 is negative 9. Alright, and so this is your equation in slope-intercept form. Y equals mx plus b. So there's your answer to number 16. Moving on to question number 18, this time we're given 2 points. So when we're given 2 points, I need to know 2 things. I need to know, okay, what is the slope and what is the y-intercept? So let's figure out the slope first. So the slope is simply the change in my y's over my change in my x's. And I go ahead and I like to label. So x1, y1, x2, y2. And it doesn't matter which one you label x1, y1, x2, y2, as long as the 1's are together and the 2's are together. Alright, so my slope then of this line that goes through these 2 points is going to be 6 minus negative 3 over 2 minus negative 1. So 6 minus negative 3 is actually 6 plus 3, which is 9. And 2 minus negative 1 is actually 2 plus 1, which is 3. So 9 divided by 3 is 3. Now, you know your slope, and you know 2 points, but you just need 1. So let's go back and use our point slope form, which is y minus y1 is equal to m times x minus x1. Alright, so I have y minus y1, which is negative 3, is equal to m, if I figured that out, it's 3, times x minus x1. Alright, so this is going to be add the opposite, so this is actually y plus 3 is equal to, and this is going to be plus 1 in there, add the opposite, this is going to be 3x plus 3. Subtract 3 from both sides, gives me y is equal to 3x. And so your slope-intercept form of equation of this line is y is equal to 3x. So your y-intercept is 0. Moving on to question number 20. Again, the same thing. We have 2 points, so let's find the slope first. So change in y's over the change in x's, and I like to label x1, y1, x2, y2, and so slope is equal to 4 minus negative 3, so it's actually 4 plus 3, and 1 minus 5. So this is 7 over negative 4. So our slope here is negative 7/4. Right, negative 7/4. Now, we know the slope and we know a point, so let's go back and use our point slope form. So y minus y1 is equal to m times x minus x1. Alright, let's plug things in. So y minus negative 3, it's actually plus 3, is equal to negative 7/4, that's the m, times x minus x1, it's 5. Alright, so let's distribute. So I get y plus 3 is equal to negative 7/4 x, and then a negative times a negative is plus, and so it's going to be 35/4. Now what we can do is we can either eliminate or we can just go ahead and subtract 3 from both sides. Now this is actually a 4 in the bottom. 4 times 3 is 12. Alright, so this is y is equal to negative 7/4 x, and 35 minus 12 is 23/4. So plus 23/4. So this is your answer in slope-intercept form. Alright, moving on to question number 22. Same thing, so slope is equal to the change in y's over the change in x's, the differences. So I like to label x1, y1, x2, y2. So m is equal to -1 minus 1/2. I'm just going to change these to a decimal from now. Might make it easier. And then I have -1/2 minus -2, which is actually +2. So this is actually -1 plus -5, which is -1.5 over, and -5 plus 2 is 1.5. And if you take a look at that, that's going to be equal to -1. So my slope is -1. Now once you know your slope, use your point slope form, which is y minus y1 is equal to m times x minus x1. So y minus y1, which is 1/2, is equal to m, -1, times x minus -2, which is actually +2. Alright, so we got y minus 1/2 is equal to, let's distribute, -x minus 2. Alright, let's add 1/2 to both sides. So this is y is equal to -x minus 1 and 1/2. We would not leave it like that. We'd say this is y is equal to -x plus 2 times 1 is 2 plus 1 is 3. And that shouldn't be a plus. I should change that. Let's go back, make sure we have a minus here. Minus 3 over 2. So here is your equation in slope-intercept form. Y equals -x minus 3/2. Moving on to question number 24. We see a graph here, and we're supposed to write the equation of the graph in standard form. Now, to review real quick, standard form is not slope-intercept form. It is y equals ax plus by is equal to c, and where your a needs to be a positive number. Alright, so your x and y's are on the same side instead of solving for y, and your a is positive, and we generally don't have any fractions. Alright, it's some kind of an integer with the a, b, and c. Alright, so what I need to do then is I need to figure out the slope, and I need to figure out the y-intercept. So in order to figure out the slope, I need to figure out 2 points of this line. And if you look really closely at this one, you're going to notice that it crosses right there. And this point is -3, -1. So there's one point. And if you look closely again, you can see that we also have a point where it goes 1, 2, 3, 4, 1, 2, 3, 4. It also crosses right there at -4, 4. Let's kind of look closely at the book and you can see that. Now, we could figure up the slope because slope is rise over run, or you could use your formula y2 minus y1 over x2 minus x1. It might be easier just to count. So how far does it rise? Alright, well, it actually, if you start from this point, it goes down 1, 2, 3, 4, 5. It goes down 5, -5, and it runs or goes over this way once. So that's just equal to -5 is the slope of this line. Now what I need to figure out is, okay, I know the slope, but what's the y-intercept? I can't see where it goes. I know it's going to be down there somewhere. I'm not exactly sure where. So what I'm going to do is use my point slope form. So y minus y1 is equal to m times x minus x1. Alright, so y minus, and just choose a point, and I'm going to choose this one right here. So y minus 4 is equal to -5 times x minus -4, which is actually +4. So I get y minus 4 is equal to -5x, distribute, minus 20, add 4 to this side, and I get y is equal to negative 5x minus 16. So this is my slope-intercept form of the line. You can see that the b is negative 16, so down here somewhere it crosses at negative 16. But the question wanted in standard form. So to standard form, I need to get the x to the right, or to the left side with my y. I'm just moving this up to here. That's going to give me 5x plus y is equal to negative 16. So this is in standard form. X and y is on the same side with no fractions, and the coefficient to x is positive. Alright, so that's question number 24. Moving on to question number 26. Again, we have the same question, type of question, and put it in standard form. So ax plus by is equal to c. So let's find 2 points, if we can, on here. And it does appear, if we look at it very closely, that it crosses, let's see, to the left 2 and down. Right there it crosses if you look really closely. And so that's negative 2, negative 1. There's 1 point. And if you look again, let's see. If you go over to 1, 2, 3 and down 1, 2, 3, 4, right there it crosses, you can see. So this is 3 and negative 4. Sometimes it's hard to determine what point it is. And so we do the same thing. So our slope is equal to rise over run. So let's just count. So let's count from this one. So we're going to go up 1, 2, 3. So up 3. And to the left 1, 2, 3, 4, 5. So to the left 5, which would be negative 5. So our slope is negative 3/5. Now, once we know that, which is your point slope form, so y minus y1 is equal to m times x minus x1. Alright, let's just plug things in. I'm going to kind of squeeze it in down here. So y minus, I'm just going to choose this point, negative 1, which is actually plus 1, is equal to negative 3 over 5 times x minus negative 2, so it's actually plus 2. Alright, so let's distribute. So I get y plus 1 is equal to negative 3/5 x, and negative 3/5 times 2 is negative 6/5. Alright, at this juncture I'm going to go ahead and get rid of denominators, so I'm going to multiply by a common denominator, and that's going to be everything by 5. Alright, so 5 times y is 5y. 5 times 1 is 5. Negative 3 over 5 times 5 is just negative 3, and you got the x. And then 5 times the negative 6/5, the 5's is canceled, just leaving you with minus 6. Alright, you can't have fractions in standard form anyway, so I went ahead and did that. Now I'm going to subtract the 5 from both sides, and I'm also going to take the x's to this side, and moving that up here. That's going to give me 3x, so the coefficient in front of x is positive, plus 5y is equal to negative 11. So this is the answer in standard form. 3x plus 5y equals negative 11. Moving on to question number 28. We're supposed to write the equation of each described line in slope-intercept form. So again, slope-intercept form is y equals mx plus b. Alright, so it says the line passing through a point, so we have a point here, and parallel. Alright, parallel, the slopes are the same. They're never going to intersect. So let's figure out what the slope of this equation is. So let's put it in slope-intercept form. So subtract x from both sides. And this one is y equals negative x plus 4. So our slope of this line then is negative 1. Well, our slope of the other one is going to also have to be negative 1 since it's parallel. So we know it's y equals negative x and then something else. We don't know the y-intercept yet, but we do know a point and the slope. So we think, alright, point slope form then. Just keep going back to this. So we got y minus 8 is equal to negative 1 times x minus 1, just using your point to plug in those numbers. Distribute, you got y minus 8 is equal to negative x plus 1. Add 8 to both sides, and this is going to give you y is equal to negative x, which I already knew that, and the y-intercept is plus 9. So plus 9, if you can see either way, you can put it right here or there. So this is your equation to the line that's parallel to the other equation that passes through the point 1, 8. Let's move to number 30. Number 30 says the line passing through 0, 4 and perpendicular. Now perpendicular has negative reciprocal slopes. So the slope of this one is negative 3. So then perpendicular means the negative reciprocal. So the opposite of that, so our is going to be positive, and then the reciprocal of 3 is 1/3. So we know our slope is going to be 1/3 x. Now, we can use the point slope form because I know slope now, and I know a point, but I recognize that this point is a special point because it tells me what the y-intercept is. Since the x value is 0, then it crosses the y-axis at 4. So this is just simply y equals 1/3 x plus 4. Sometimes you can save yourself some time by just recognizing what's in the problem. Moving on to question number 32, we have the line passing through 0, 1 and parallel to 3x plus y. And I'm supposed to put this in standard form. So this is going to end up looking something like this. ax plus by is equal to c. Alright, so if it's parallel to this one, that means it has to have the same slope. So let's figure out what the slope of this line is. So put it in slope-intercept form, and this slope is negative 3. So my slope is also going to be negative 3. Now, since I know that right here I can use point slope form, or since I can recognize immediately that I know my y-intercept, this is plus 1. Now that's slope-intercept form. I'm supposed to put it in standard form. So let's get the x's on the same side as the y. So it's 3x plus y is equal to 1. And this is in standard form. Moving on to question number 34. Line passing through negative 1, 3 and perpendicular to 3x plus y equals 2 in standard form. So again, I want to find the slope of this one. This is going to be important to me. So I get y is equal to negative 3x plus 2. Alright, now this slope of this line is negative 3. Mine is going to be perpendicular. Perpendicular slopes have negative reciprocals of each other. So mine is going to be y is the opposite of negative 3, which is positive 3, and the reciprocal of that number, so the reciprocal of 3 is 1/3. So mine's 1/3 x. Now, I don't know the y-intercept, so I'm going to have to use a point slope form. So I'm going to come over here and say, well, y minus y1 is equal to m times x minus x1. They didn't give me the y-intercept this time. They just gave me a point. So I got y minus 3 is equal to 1/3 times x plus 1 minus a negative. So y minus 3 is equal to distribute 1/3 x plus 1/3. Now, at this juncture, since I'm going to have to put in standard form anyway, I'm going to go ahead and multiply everything by 3. So this means this is 3y minus 9 is equal to, that cancels the denominators, x plus 1. Now, let's get my x and y's on the same side. Gives me negative x plus 3y is equal to 10. Now, I'm supposed to have a positive coefficient to x, so I simply multiply everything by negative 1, or you can just simply change the signs. So x minus 3y is equal to negative 10. And that is in standard form. And moving to the last problem in this section that we're going to do, question number 42. If 3x plus y is equal to 2 and ax minus 3y is equal to 10, and these two lines are parallel, what is the value of a? Well, parallel means the slopes have got to be the same. So let's take a look at this first equation, and let's figure out the slope. So I have y is equal to negative 3x plus 2. So the slope of this line is negative 3. So my slope has to be negative 3. When I take a look at the second equation, let's go ahead and solve it for y. So minus ax minus ax, so I get negative 3y is equal to negative ax plus 10. Divide by negative 3, and I get y is equal to positive a over 3x minus 10 thirds. Now what I need is, I know that this part has to be equal to this part. So I'm going to set that equal to each other. So I'm going to say, well, negative 3 must be equal to a over 3, and solve for a. So multiply both sides by 3. This cancels, and I get negative 9 is equal to a. So I know that a must be equal to negative 9. And that concludes section 2.3.